So the last thing we need to look at is something called absolute and conditional convergence. So if we think about this function here where we got the sine of n over n squared, we got sine of 1 over 1, sine of 2 over 4, sine of 3 over 5. These are going to have some positive and some negative values up here. And so on the bottoms are going to be our, well, n squared. This should be, what should this be? This should be 9, right? So is this an alternating sequence? Not exactly. So no, it's not alternating. Are all the terms positive or negative? No, we got some of each. So some will be positive, some will be negative, but they don't follow a regular pattern. So let's think about this. The absolute value of this function, we might be able to figure something out about that. And so if we have a sub n is the absolute value of sine n over n squared, well, we know this. We know the sum of the absolute value of sine n over n squared is less than or equal to n equals 1 to infinity of 1 over n squared. Okay? Because sine n, the biggest the sine can be is 1, or the lowest it can be negative 1, but the absolute value makes it positive. And we know that this converges by the p-series test because the power is bigger than 1. So we can say that the absolute value of this converges. And it turns out that because of this next theorem here, that if the absolute value of a function converges, then the original function converges also. That's what we call absolute convergence. Okay? So we can say this converges. Okay? First by comparison, and then by this absolute convergence test or theorem. But be careful, the converse is not necessarily true. So the converse would be if we know that a series converges, then its absolute value converges. For example, if we take this alternating series here, we have negative 1 to the n plus 1 times 1 over n. That gives us 1 over 1 minus 1 over 2 plus 1 over 3, so on and so forth. This converges, all right? And it converges by the alternating series test because we know that the limit as n goes to infinity of 1 over n is 0. And also we know that 1 over n plus 1 is less than 1 over n, or equal always. So it's non-increasing. So therefore, the series from 1 to infinity of negative 1 to n plus 1 over 1 over n converges by the alternating series test. Now, the original function converges, but does the absolute value of this converge? Well, keep in mind here that the absolute value of this just drops the negative 1 and is 1 over n. And does the sum of 1 over n converge? No, we know this diverges because it's our harmonic series, and we've proven that already.